to go over some more work with quadratics. I know we spent a bunch of time with quadratics on our previous unit. We had 2 lessons on it, really just one, but kind of spilled over into the second. But the reason I want to go over more quadratics is because we didn't take any time talking about what it looks like to graph them, finding characteristics of their graphs, and talking about the different forms that you're used to working with from your algebra days. So just a heads up, the vocab I'm using from this textbook is going to look a little different. Don't stress about it, right? Your work in Algebra 2 focused on the standard form of a quadratic being ax squared plus bx plus c. And in this book, we actually call that the general form. And your work last year, you probably used the vertex form for a times x minus h, all of that squared plus k. But in this book, we call that the standard form. So again, I know it can be a little confusing. Don't really worry about that. Just make sure you feel comfortable with all of these vocab words here. So I'm hoping that this is all really just a review. You'll see the axis of symmetry splits the parabola into 2 symmetrical halves, and it always goes through the vertex. All right, at that point. In this case, because this parabola is opening up, the vertex is a minimum value. And then you'll notice we have a y-intercept and we have x-intercepts. You'll see sometimes that we won't have x-intercepts. You already have seen that before with our work with imaginary numbers. Okay, so let's talk a little bit about these 2 forms. Right? If you look at this first one, which I know they're calling standard form, you're used to this being called vertex form. It's the easiest one to get the vertex because it's just h and then k. Now, the key thing when you do this, if you notice inside the parentheses here, you'll see it says x minus h. So just like we've talked about in our very first unit together, make sure you're always thinking opposite when you write down that letter h. All right, the general form is a little trickier. The vertex, based on your work with the axis of symmetry, if you remember how to find that formula. So the axis of symmetry is x equals the opposite of b over 2a. And so when you find the vertex, because the axis of symmetry has to go through the vertex, the x value will be the opposite of b over 2a. And then to find the y value, you just evaluate the function at that point. All right, so it looks like there's a lot going on, but I'm hoping with your experience of doing this last year, you'll be able to kind of pick it up. All right, so let's go ahead and determine the vertex, the axis of symmetry, the zeros if there are any, and the y-intercept for this parabola. So start the vertex. Vertex is down here, again, because it opens up. This is what we call an absolute minimum for the vertex. So the vertex is going to be 3, 1. The axis of symmetry, again, has to go through that vertex point, so it's always going to be x equals a number. And in this case, you can see the value goes through as x equals 3. That shouldn't be really that surprising because if you look at the x value of your vertex, it is 3. Then we have any zeros. Now, when I look for zeros, right, I'm looking for where does the function cross or touch the x-axis. And if you notice, this never touches or crosses the x-axis. So we actually have no zeros. So I'm going to write none for zeros. And the y-intercept in this case is going to be 0, 7. All right, so that's it for finding the characteristics for this parabola. Okay, now, from this idea, all right, we can actually write the function in one or both of these forms. As again, I said, when I say standard form, I'm really talking about the vertex form. And when I say general, I'm talking about the standard form that you used last year in Algebra 2. So essentially, I'm gonna do both, right? You can do whichever one you want first. I think it's easiest to write this in using my vertex. All right, so essentially putting it into what we're calling now the standard form. So my vertex is -3, and then, excuse me, not -3, sorry about that, -2, -3. Okay, now it says if we think about it being translated from our parent function x squared, that means I went 2 units to the left and 3 units down to get to my new vertex. So when I write this, we're using my vertex, all right? And when you do this, make sure you put that A. We're going to have to find what that first coefficient is going to be. Times, right? I'm moving 2 units to the left. So if you look at my vertex, it says -2, but you got to think opposite when you write it inside the parentheses. So x plus 2, all of that squared. And then whatever your y value is for your vertex, that's just going to be my vertical shift. So this is the answer, but you'll notice I have that letter A that I need to solve for. You can use any of these points in this table. I'm just going to use the first one I noticed when I graphed it was -4, -1. So I'm going to use that point, plug in -1 for the y, plug in -4 for the x, and I'll use this to solve for my letter A. So I get A times -2 squared minus 3. So that's going to be 4A minus 3. Moving the minus 3 over with addition, I get 4A equals 2. Dividing both sides by 4, I get A equals 1/2, right? 2/4 reduces to 1/2, okay? So to finish writing this using my, what we're calling now standard form, or with that vertex, is 1/2 times x plus 2 squared minus 3. Now, if you wanted to write it in terms of the other form, right, so I'll kind of just make a note that I'm doing the other form now. I'm going to take this and expand it. All right, so I'm going to leave the 1/2 alone. And if I expand x plus 2 squared, as we've kind of done periodically over these first couple of units, right, hopefully you're getting to a place where you can do this inside your head. X squared is x squared. X times 2 is 2x, but you double it and get 4x. And then 2 squared is 4. Don't forget that we still need to distribute that 1/2. All right, so half of all of this is going to be 1/2 x squared plus 2x plus 2, and then minus 3. So now if I just combine my last two terms, because they are like terms, I'll have my answer. So 2 minus 3 is -1. All right. So again, I know it's kind of weird because we're kind of switching this. Right. I'm calling this one that's highlighted in the turquoise my standard form now, and this one highlighted in the green my general form. Not that concerned if you would like to keep the other ways. But the key thing you need to know is that what I highlighted in turquoise and in green, those are the same thing. So if I were to graph them in Desmos, they would end up being the exact same parabola. You wouldn't actually be able to tell which one is which, right? They're the same. Okay, let's go into finding my this idea of rewriting like we did before. So we're going to find the vertex of this quadratic, which is written in what, again, general form. If you want to call it standard form, that's fine. I don't really care. All right, so I'm going to find the vertex first. And then using that, I'm going to write this in standard form or with that vertex. So the first thing I need to do is, if I know that this is A is 2, B is -6, and C is 7, I'm going to use that formula for the axis of symmetry, even though I don't need to know the axis of symmetry, because this gives me the x value for my vertex, so the opposite of B over 2A. So if I do, I've had students every year that I do this. They ask, is the negative with the B? And honestly, it really doesn't matter. As long as either you do the opposite of B on top or you do the negative out in front of the entire fraction, you should get the same thing. So it's up to you. Personally, I usually just deal with that negative right away with the B. So the opposite of that B is going to be 6 over 2 times my A value of 2, which gives me 6/4 or 3/2. So my x value is going to be 3/2. Now to find the y value, I'm going to evaluate this function, this f of x function, don't know why I wrote g, sorry about that. This f of x function at 3/2. So I'm going to do 2 times 3/2 squared minus 6 times 3/2 plus 7. Now I'm going to go ahead and take the time to do this mentally. You guys can use Desmos on literally everything you do in here. So if you would like to just go to Desmos and type this straight in, right? I've got Desmos queued up for me right here. If you want to type it in, feel free to type it in. I'm just going to use my understanding of fractions to take care of this. So 3/2 squared is going to be 2 times 9/4 minus, this is going to end up being minus 9 plus 7. All right, so if I reduce that and make a common denominator, I'm going to get, that's going to be 18/4, but that can be reduced to 9/2. Then this would be 18/2, and then 14/2. So if I do all that math, I get 9 minus 18, which is negative 9/2. Negative 9/2 plus 14/2 is 5/2. So that is my y value. So my vertex is going to be positive 3/2 and positive 5/2. Again, you could even just type this into Desmos and it'll show you the vertex. All right. Decimals are fine, right? 1.5 and 2.5, no worries. All right. So now to use this in terms of standard form, the nice thing is that when I said that my letter A was 2, that is the exact same letter A in my standard form / now we're talking about in vertex form. So I'm going to rewrite this as, don't forget that 2, x, think opposite here, minus 3/2 squared plus 5/2. Okay, so that again matches the general form that was given to us in the problem. All right, we have an equation here, and we want to write it in general form, and then obviously also we're going to do that to write it in vertex form. So I'm going to first write g of x equals x squared minus 6x plus 13. All right, and something interesting about this is you could, if you wanted to, if you know how to, what we just did, we found the axis of symmetry, which is our x value for the vertex. You could do that. Then you could go ahead and plug it in and find the y value and use that to find it written in standard form. That's with the vertex. But I just want to show you, have a little fun here by using your understanding of completing the square, which we just did in the previous unit. So I'm going to write x squared minus 6x. I'm going to leave a space. And now this is the cool part. All right, leave the 13 on this side. So if you remember from our days in the last unit, we have b over 2 squared, which is going to be negative 6 over 2 squared. All right, so negative 3 squared, which is 9. All right, so now here's the cool part. So you're going to have plus 9 here. All right, but now, because that's going to end up being what I factor, I have to, I'm going to do air quotes here. I know you can't see me, but I'm going to air quotes, add 9 to the other side. But because I'm writing on the same side, I'm going to subtract 9. Okay, so what you end up doing is you get x minus 3 squared, and then you have plus 4. All right, so that's for me, that's faster than finding the axis of symmetry and then plugging it back in. But you could totally do that, right? The opposite of negative 6 is going to be 6 divided by 2 times 2. 2 times 1. That's going to give you a positive 3 for your x value. Plugging in 3, you get 9 minus 18, which is negative 9, plus 13 is 4. So you get the same thing. I know you're probably thinking, what did you just say? You get the same thing if you do it the way we did the previous one. But personally, I wanted to show you how cool it is to complete the square within this. All right, sick. Let's go to the next one. All right, so domain and range. Domain is the simplest. The domain of a quadratic function is always all real numbers. So you'll see I'll always put the domain and range as negative infinity to infinity. Now the range is a little bit different, right? I'll show you here, right? I'm not going to do the domain for these because they're the same, right? It's always all real numbers. But let's talk about the range for a parabola that opens up as opposed to a parabola that opens down. You'll notice when it opens up, this vertex is what we call a minimum. So our lowest y value is 1, and our highest y value would be infinity. When it opens down, your vertex is now a maximum. All right, so your lowest y value is actually going to be negative infinity, and your highest y value from your vertex, right, would give you the end of that range. All right, so just keep in mind when you're doing this for the domain and range. So let's try the domain here. So we know the domain of a quadratic is all real numbers. Now, if you wanted to, you could take the time, right? You know the formula for the axis of symmetry, but to be honest, I really don't want to if I don't have to, right? I have a graphing calculator at my disposal. So why not just type this in? Because when it's written in this form, which I'm calling general form now, you're going to have to do some work to find that vertex. But if we know the general form, we can just plot it, right? Negative 5x squared plus 9x minus 1. Confirm. Yes. And if I click right there, you can see that my vertex is 0.9, comma, 3.05. Now, because I'm doing the range, and this parabola opens down, my lowest y value is going to be negative infinity, and my highest y value is going to be positive 3.05. So my range is negative infinity to positive 3.05, and make sure you use a bracket. Right? This one's a little simpler when it's written in what I'm calling now standard form, right, where you can see the actual vertex. You can literally just pull the vertex out. And again, domain, all real numbers. But for the range, right, you notice it's opening up. So my vertex of positive 4/7, comma 8/11, right? I know it's a lot there, it's fractions, right? That's going to be a minimum. So my lowest y value is going to be 8/11. All right, and it's going to go all the way up to infinity. Again, if you need to graph this on decimals, right, you've got it. Go ahead and take the time to graph it if you'd like. Okay. Kind of already mentioned this, right, in the idea of talking about domain and range, right, especially with the range, that your vertex, when it opens up, is going to be a minimum, and your vertex, when the parabola opens down, is going to be a maximum, right? So what we can do is we can use this idea of quadratics to end up maximizing certain word problems. So this first one is talking about a backyard farmer wants to enclose a rectangular space for a new garden within her fenced backyard. She has purchased 80 feet of wire fencing to enclose 3 sides, and she will use a section of the backyard fence as the 4th side. So what I thought was, all right, okay, so this right here is her back fence. All right, so we don't need to worry about that. But we do care about the rest of it, right, which is going to give me my total of 80 feet, right, that I purchased, or that she purchased. So it says the fencing that is perpendicular to the existing fence is going to be labeled as our length, and I'll label this one as the width. So in terms of writing down the perimeter of my area that I need to, or I shouldn't say area because we'll talk about area in a second, the perimeter of my enclosed rectangular space in terms of dealing with the 80 feet is going to be 2L plus W, and that has to total 80 feet because that's what she bought. All right, doesn't have to, but we'll see that by doing that we can maximize the area of this garden. Okay, in terms of the area, right, you guys know that the area is equal to length times width. Okay, so you'll notice that in both of my formulas I've got 2 unknowns. So what I'm going to do is with my area, I'm going to leave that alone, but solve using my perimeter. I'm going to solve for W to get 80 minus 2 times the length. All right, so if I replace, this would be length times 80 minus 2 times the length, which is equal to 80L minus 2L squared. Or in other words, this is a quadratic function. So my area function is going to be negative 2L squared plus 80L. All right, so this is the formula. This answers letter A, if you will. And then to solve for letter B, all right, to maximize this, if you notice, the number in front of L squared is a negative. So that means I'm going to be my parabola, if you were to just kind of sketch it, and you could if you wanted to, right? If you were to sketch it, you know it's going to be opening down. So my vertex, right, that vertex would be a maximum. So because that vertex is a maximum, if I find the vertex, right, that would give me my x coordinate, would give me the dimension for the length that I need to use. And then the y value would give me the actual total area that I've maximized for this garden. Okay, so let's find using the axis of symmetry. Let's go ahead and find it. So it's going to be L equals the opposite of B. So the opposite of 80 over 2 times negative 2, which is going to be negative 80, over negative 4, which is positive 20. All right, so the dimensions that I need to do are, I've got 20 feet. Let me do a different color so you can see on my sketch. So I'm going to use 20 feet, right, for this side of the fencing, 20 feet of wire over here. And then for my width, if I do my math from my thing that I have, 80 minus 2 times L, which is 20. So my width is 80 minus 40. So my width, but you probably didn't need to do this. You can see it is 40 feet. So this one's going to be 40 feet. So that's it in terms of this problem, right? That answers letter B, right? Letter B is kind of in my sketch. But I did want to show you that if you were to take the time to plug in that 20 into the area function, so if I evaluate that area function at 20, you get 20 squared times -2 plus 80 times 20. So that's going to be, let's see, 20 squared is 400. That's -800 plus 1600. So you get 800 square feet is going to be the maximum area. All right. Now, if you wanted to kind of synthesize this in your brain, right, using your graphing technology, if I were to go graph that area function, -2L squared plus 80L, let's go and do that now. -2, I'm going to make it x squared plus 80x. Right? And then I'm going to duplicate and make my table. Let's see, let's do 10 for the length, 12, 14, 16, 19, 20, 22. Sorry. 22, 24, 26. And I'm going to show you when I zoom in. Right, you can see, zoom out a little bit. No, let's stay zoomed in. You can see that my maximum is going to be my vertex up here. And that point is 20, which we found was the dimension, the amount of wire we should use for those lengths. And then 800 is that total maximum area that we found when we plugged in 20. So 800 square feet. All right. Okay, let's do the next page. So the next page is talking about finding x and y intercepts. Now I'm hoping that you'll see the connection between what we did in with quadratics in the previous unit. All right, finding x intercepts or solutions or zeros of quadratics means you really want to try factoring first. All right, if that doesn't work, I'm going to see if completing the square makes sense to try. If that doesn't work, then I'm going to use the quadratic formula. You also do have graphing technology, so you can immediately see by graphing them on Desmos wherever it touches or crosses the x-axis. Those are the x-intercepts or the roots. In terms of the y-intercept, just like you can do for any other function, plug in 0 for x, and we'll give you the y. If it's written in the general form, right, that ax squared plus bx plus c, your letter c is also always the y-intercept. So in terms of finding the y-intercept, all right, we're going to evaluate the function at an input of 0, and then find the x-intercepts at locations where the entire function f of x is 0. Okay, so you can see in the figure that we've got kind of three things that could possibly happen. Right, you'll notice that on this one we have the first one, we have no x-intercepts, right, because we never touch or cross the x-axis. This is where you would have those complex solutions, right, that a plus or minus bi. Then when you touch, but you don't actually cross it, that's where you have one x-intercept, right? When you did the discriminant, that's where you had your radicand would be 0. And then the two x-intercepts is where that's traditionally what you would see, where you have it crossing twice. So here we go. I think the y-intercept is the simplest to find. All right, since this is written in ax squared plus bx plus c, my c value here of -2 is the y-intercept. For the x-intercepts, if there are any, I am going to set this equal to 0, so 3x squared plus 5x minus 2 equals 0, and I'm hoping that I can factor this. So I notice that I don't have a GCF to factor out. I have an a that's not equal to 1, so I'm going to do the slide divide bottoms up. So let's slide that 3 back. Get x squared plus 5x minus 6. Then I'm going to factor this as x and x. So I need factors of -6 that add to 5. So that's going to be +6 and -1. Then I'm going to divide those two numbers I chose by the number that I slid, right, that 3. So to finish factoring, I have x plus 2, because that divides nicely. And then if you do the bottoms up, you get 3x minus 1, and all of that is equal to 0. So to solve this, I get x equals -2 and x equals positive 1/3. So those are my two x-intercepts. So I'm going to write them down as ordered pairs. So -2, 0, and positive 1/3, 0. Again, right? This question doesn't say you have to show really any work. So if you want to just type this into Desmos, you could graph it and find those all three intercepts. Okay. All right, we had this one earlier in the notes where you have your g of x function, if I write it in the general form, x squared minus 6x plus 13, right? And then you notice that I completed the square to change this into, now that we're calling standard form, which is really with my vertex. So it wants us to find any x and y-intercepts. So because it's in this general form, again, I think the y-intercept is pretty straightforward. It's just going to be 0, 13. All right, to find the x-intercepts, what I'm going to do is I'm going to set it equal to 0, and I'm hoping I can factor. Now, unfortunately, there are no factors of 13 that add to -6, so this is where I ask myself, is this a candidate that would make sense for me to complete the square? It is, because my a is 1, that has to be true. My b is even, right? 6 divided by 2 is going to be fine. So I have no issues with completing the square. So I have minus 6x. This time I am going to move that 13 to the other side and get -13. You can show all the work. I probably should, but since I just did this one earlier, you'll notice that my b over 2 squared was going to be that 9. All right, so this is x minus 3 squared equals -4, right? Alarm bells are already going off for me. If you don't feel that right now, it's okay. Take the square root. I'll finish it so you can see the square root of both sides. So you get x minus 3 equals plus or minus. Now here we go. The square root of 4 is 2, but it's not the square root of 4. It's the square root of -4. So this just needs to be 2i. So x equals 3 plus or minus 2i. So here's the deal, guys. Because my x-intercepts, using air quotes here, you can't see it, because my x-intercepts are complex numbers, right? That's a real piece plus an imaginary piece, and a real piece minus an imaginary piece. The x-intercept here I write is none. Because when I graph this, if you were to sketch it, you would notice that it does not touch or cross the x-axis. All right, let's do one more and then we'll be done. So another type of problem that is seen pretty much every time you learn this in algebra, algebra 2, now pre-calculus. All right, and if you take any type of physics class, usually the first unit will have something to do with displacement, where you've got someone like throwing a ball into the air, maybe they're dropping an object. Excuse me, in this case, we're throwing, because as one does, throwing a rock upward from the top of a 112-foot cliff overlooking an ocean. It gives us the speed at which you throw it, right? So the rock's height above the ocean can be modeled by the equation, which you'll notice is a quadratic. So we're going to find all three of these things. When does the rock reach the maximum height? So to do this, I know that because it opens down, right, that negative in front of the 16t squared means it opens down. So my vertex will be a maximum. So if I find the vertex, so I'm going to put find the vertex. This will give me my answers actually for A and B. So let's do the axis of symmetry formula, all right, which in this case is going to be T equals the opposite of B, so -96 over 2 times A, which is 2 times -16. It's going to be a positive, and 96 divided by 32 is going to be 3. All right, so when does the rock reach the maximum height? The answer is 3 seconds. That's when it reaches the maximum height. Now, to find the maximum height that it actually achieves in 3 seconds, we're going to plug that in. So h of 3. So -16 times 3 squared plus 96 times 3 plus 112. All right, so when you do that, all right, you're going to get, I guess I should type this into Desmos, so I just use my phone calculator. So I've got 9 times -16. All right, plus 96 times 3, and then plus 112. So I get 256 for that maximum height. All right, so 256 feet is going to be that maximum height. Now, the last question says, when does the rock hit the ocean? All right, so this is where, if it's hitting the ocean, it's where the height of the rock is 0. And h of t is that height above the ocean where that rock is. So h of t is essentially telling you that is the height of the rock. So I'm going to replace that as 0 and solve for t, because if I find out what values for t would make this become 0, right, that would give me the time at which the rock is no longer above the ocean, right? It's in the ocean. All right, so I'm going to try to factor. I'm going to factor out the negative 16 to get t squared minus 3t. That's not 3. It's minus 5. My bad. Nope, 6. Whew. And then 112 divided by 16, I believe, is 7. Let me confirm these for you. So I have 96 divided by 16. That was 6. Good. 112 divided by 16 is 7. Great. So that's going to give me, did I change that symbol? I don't think I did, Douglas. There we go. So make sure, since you're factoring out the negative, all the signs have to change. So t squared minus 96t minus 7. Just like I said before, I don't care about anything that I factor out that doesn't have a variable. So that negative 16 essentially is meaningless. Let's do our factors. We get t, let's see, minus 7 and t plus 1. So my two answers are 7 and negative 1. Now we're dealing with t is time, right, in seconds. So this negative 1 doesn't make any sense because it can't have negative seconds. So to answer letter C, in 7 seconds, the rock will no longer be above the ocean. It will hit the ocean. Now that was a lot of work there, but if you had just taken the moment to graph this, you could actually find out all of these answers using your graphing technology. So I'm going to type in negative 16 x squared plus 96x plus 112. So let's get rid of this. Negative 16 x squared plus 96x plus 112. I'm going to make it a table. And I'm going to deal with, remember, only positive or 0 and positive time. So, and we said it went to 7. Should be good. Hit that thing. Excellent. So here we go. You can notice here's our y-intercept, obviously starting at 112 feet above, since we're on that cliff. We've got our 3 seconds. So in 3 seconds, our rock is going to reach its maximum height of 256 feet. And then in 7 seconds, it's going to reach the ocean. It's no longer above the ocean anymore. In 7 seconds, it's at 0 feet above the ocean. All right, guys, that is it. All right, that finishes that question, finishes these notes. Don't forget to practice the links. Good luck.